Hello, everyone. And at this point, we are still continuing on the concept of the trigonometric integrals. And this is another interesting problem that I want us to solve. And before we ended the previous example, I mentioned that in general, we try to write an integrand involving powers of sine and cosine in a form where we only have one sine factor and the remainder of the expression in terms of cosine, or only one cosine factor and the remainder of the expression in terms of sine. And I also mentioned that the identity sine squared plus cosine squared equal to 1 is a very powerful tool that, in a way enables us to convert back and forth between even powers of sine and the cosine. So this is a very an example that would help us to understand it better. And as time would permit, I would lay a general foundation for everyone to understand it because it's a very powerful tool, especially in the area of the Fourier series analysis and all of that. It's a tool that is being deployed over there, so it's important that we understand it. All right, let's get going. Now, how do we solve this problem? Now, with this, we could convert the cosine squared x into another form, right? But we could, but we would also be left with an expression in terms of sine with no extra cosine x factor, right? Instead, we would separate a single sine factor and then rewrite the remainder or the remaining sine um, to the power 4 factor in terms of the cosine. Okay, what am I saying? Let's look at it together. And let's take our time so that we understand it better. So now if I have sine to the power 5 and cosine squared x. Then what I was trying to say is that we can write this particular term as such as sine squared x all to the power squared, okay, cosine squared x sine x. So that was all. That was what I was trying to say. Okay, because as I mentioned, the general thing that we try to do is that anytime you have integral involving powers of sine and cosine, we would try our best to ensure that we have only one sine, factor, and then the remainder of the expression in terms of cosine, or only one cosine factor and the remainder of the expression in terms of sine. And then the identity, as I mentioned, sine squared plus cosine squared equal to 1 will be another powerful tool that will help us to, convert back and forth between the even powers and of sine and cosine. So that's what I mentioned, right? So let's get going. So with this, so over here, what we are doing is to try to simplify some things before we delve into the problem. Okay. So the sine squared x can also be written as what? As we mentioned, this is what sine squared x plus or cosine squared x equal to 1. Okay? So whichever case I could make any of them to stand alone. Now, if I to get this expression, I just have to move the cosine squared to the other side. And by moving that, I should have what? 1 minus what? Cosine squared x, okay? All squared cosine squared x sine x, okay? Now, at this point, this is good that it's imperative that we now substitute u for cosine, okay? And now, so we'll say so we are doing substitution, okay? So let u equal to the cosine of x, which means that my du should be what? Should be minus sine x dx, okay? So when that happens, so this implies that you should be able to have the integral of, now we look at it. So now the solution for the main problem now becomes what? The integral of what? Remember, we have already I mean, for just for a better understanding, so let me just repeat certain things so that everybody would benefit. It's just a repetition of, because remember we've already simplified the integral, so I'm just repeating the stuff over there. That's the simplification that we did earlier on, okay? And now we said that we made u to be cosine, right? So in that case, we're going to have 1 minus or u squared all to the power all to the power 2, and then u squared minus du, okay? Because remember, um, so this expression will be captured by this, okay? Will be captured by this thing, this expression here. So let's take note of that. And that's why we have this. So now at this point, all that we need to do is to simplify, right? And by simplifying, we should have, we can pull out the, the negative outside. And by pulling out the negative and simplify this, you should have u squared minus 2u to the power 4 and plus what? Plus u to the power 6 du. And by applying, the basic properties of integration, you should be able to have this. So we increase the power by 1 and divided by the increased power, okay? So we increase the power by 1 and divided by the increased power, and that should give you the result. Okay? So that's what we should have. Let me say plus c, okay? Plus the c, constant c. Yeah, so this is a solution for the problem we are at this point we are not done. We have to remember we switch everything from x to u, so we have to do reverse substitution. Okay, what is u now? The question, what is u? Our u was cosine, right? So that become cosine cube x on 3 minus 2 on 5 cosine on that, and then plus what? Cosine, and then plus our constancy. Okay, very important. So let's take note. Let's take note of that. And at this point, if you have not subscribed, please do so. Comment, like, share, and help demystify the myth around mathematics. As I mentioned, we want to create a community where the members will be free of from the mindset that math is difficult and math cannot be learned. Okay, but friends, I must admit that math can be learned. With the right, with the right materials, with the right content, I think you should be fine with that. Thank you so much.